Very good afternoon to all student members and respected faculty members from various colleges. I welcome you all for the day 4 workshop on drone programming and autonomous flight. So today I am very much delighted to have you all here for the fourth day skill development program on so-called topic importance of drone programming and autonomous flight. It is quite evident that drones have rapidly evolved from simple remote controlled flying devices into intelligent autonomous systems capable of performing complex tasks across numerous industries. So in today's workshop, we will explore the advanced technology that make modern drones more intelligent, efficient, and capable of autonomous decision making. Let us begin our exciting journey into the future of unmanned aerial systems. So this is our today's objective for the day 4 workshop. The main objective of today's workshop is to provide a comprehensive understanding of drone technology from both engineering and programming perspectives. You will learn about the drone components, flight controllers, autonomous navigation, mission planning, drone programming using Python, and the integration of artificial intelligence and computer vision systems. By the end of this session, you will have a solid foundation to start developing your own autonomous drone applications. We will straight away move on to the workshop agenda. Let us have an overall glance. Today's program has been carefully structured to cover the complete drone ecosystem. We will begin with drone fundamentals and applications, then move into the hardware and flight control systems, then learning the importance of programming concepts and autonomous mission planning. Later, we will explore how AI-powered drone technologies support different industry applications as well as safety regulations. And finally, we will conclude with a practical project demonstration, say obstacle detection and avoidance using drone simulation. And finally, we will end up today's workshop with a discussion orienting to the future opportunities in this field. So these are our today's objective as per the session agenda. Already we have discussed a lot regarding introduction, basic drone components. I would like to just recall in small nutshell. I don't want to waste much of the time in redefining the drone problem definition and listing of the drone components. In the previous 2-3 lectures, I think we have discussed lot of information in the basic fundamental introduction as well as the components of drone. So I'm going to focus more on the programming simulation and the autonomous concept on drone. So let us quickly go through the introduction. Just to recall what we have learned in the past 3 lectures. The drone is nothing but an unmanned aerial vehicle. Its primary ability is to assess the difficult locations very quickly and safely in order to make them one of the most impactful technologies of our time today. So earlier, drones are of manually operated with the human intervention. But here today in the day 4 lecture, how drones behave more intelligently in an autonomous way without the intervention of the human pilot. When coming to the drone components, so to understand how a drone flies, so these are the major components. With the help of that, it functions very effectively. So the most important thing is the rigid support frame. Over the frame, motors will be mounted. The motors generate thrust force. So while the propellers convert the rotational motion into lift, so electronic speed controllers used to control the motor speed. The battery supplies electrical energy to all electronic onboard systems. At the center is the flight controller, often referred to as a brain of the drone. It continuously processes the sensor information from GPS modules, accelerometers, as well as gyroscope and barometers to maintain the flight stability and its direction. Every components work together as a part of fully integrated system. So coming to the next one, flight controllers. Here we are going to see two different kinds of open source, the firmware that has been used for autonomous navigation purpose. The flight controllers are responsible for ensuring stability navigation and autonomous operations. Here, two of the most popular open source platforms are given here, Adro Pilot and PX4. Adro Pilot is commonly used in research and educational environments because of its wide stability and extensive hardware support. PX4 is known for its modern architecture and strong integration with robotics and autonomous systems. These platforms allow the developers to create advanced autonomous behaviors while maintaining safe and reliable flight performance. Let us now see some of the core concepts of drone programming fundamentals. Programming is what transforms a drone from a flying machine into an intelligent autonomous systems. So communication between the software and the drone typically occurs through micro air vehicle link protocol. Using drone kit and Python, developers can create mission scripts that automate the takeoff, navigation, obstacle response, data collection, and landing procedures. Programming allows the drone to execute complex missions with precision and minimal human intervention. So here you can able to see the sample Python subscript for the drone programming basic operations. Now let us move on to the autonomous navigation. Autonomous flight depends on accurate navigation and positioning system. GPS waypoints define the route. It must, it must be followed very effectively. There are some advanced algorithms used to calculate the most efficient path between the multiple locations. Sensor fusion combines data from GPS, inertial sensors, and barometric sensors to determine the drone's exact position and orientation. Features such as auto mode, loiter, return to launch, and guided mode make autonomous operations both practical and reliable. So here we will now discuss a simulation exercise for path navigation, obstacle detection, and avoidance using the Python simulation programming. So this is the so-called the environment which has been simulated here for your reference. The name of the exercise is drone obstacle detection. So using proximity sensor, the drone can able to find the distance away from the goal point. So based on which it will adjust the path to be navigated before it reaches the goal point. That is the target or objective point. So here is the actual speed of the drone, altitude, the number of obstacles it is found. So everything will be calculated using the algorithm called artificial potential field algorithm. It is one of the basic Python simulation program. Now let us reiterate the experiment once again by clicking the reset button. If I want to add multiple obstacles, I can do it simultaneously. So once again, I'm reiterating the same experiments by creating multiple obstacles. Here, there are two obstacles are there. The drone senses the obstacle. Accordingly, it will try to navigate the path to reach the final goal point or objective point. So the distance of the obstacles are measured here. The number of obstacles that are detected here in this simulation exercise is 80. So this is one such simple simulation exercise in offline mode we can able to conduct. So this will be the best outcome to serve for the final real-time application. When you go to the real-time environment, we can able to do the same kind of thing. How the drone successfully passes all the obstacles to reach the final destination point. And these are the output that has been listed out here. Now we will resume back to the PowerPoint presentation mode. We will see the next part of the segment, artificial intelligence and computer vision. AI is enhancing the drone technology nowadays gradually. Modern drones can detect objects, avoid obstacles, track the moving targets, and make intelligent decisions in real time. Using cameras, computer vision algorithms, and deep learning models, drones can interpret their surroundings and respond accordingly with respect to a given situation. These capabilities are more essential for applications including surveillance, inspection, search and rescue operations, and autonomous delivery systems. Here are some of the safety uh, procedural guidelines are given as per the Directorate General of Civil Aviation. As drone technology becomes more widespread, safety and regulatory compliance become increasingly important. In India, drone operations are being regulated by the Directorate General of Civil Aviation. Operator must understand the drone classifications, registration requirements, altitude restrictions, and the no-fly zones. Before every flight, a complete safety inspection should be performed to ensure safe and responsible operations. One thing you have to remember, safety is always the first priority in aviation. So what are the various tools and development ecosystem in autonomous flight? Several software tools support drone development and testing. Mission Planner and Q Ground Control are widely used for mission planning and flight monitoring. Simulation platforms such as ASBO and software in the loop allow developers to test the missions safely before real-world deployment. DroneKit, OpenCV, and PyTorch provide powerful capabilities for programming, robotics integration, computer vision, and AI applications. These tools form the basic foundation of modern autonomous drone development. Here are some of the sample examples for hands-on project, which you can do it by yourself. In this workshop, participants will design and execute an autonomous survey mission. The project involves setting up simulated drone environment, creating a waypoint missions, programming autonomous flight behavior, and analyzing the mission results. Participants will also explore the methods for obstacle reduction and the mission optimization. This practical exercise provides valuable inputs in real-time drone mission development. Like similar to the simulation exercise which I have demonstrated you can develop your own the project objective and make a hands-on experience in finding out the obstacle reduction and avoidance. Next, future of drone technology. The future of drone technology is filled with exciting possibilities. Artificial intelligence will enable fully autonomous decision making. Drone swarms will collaborate to perform large-scale operations efficiently. Urban air mobility systems will introduce autonomous air transportation in cities. Emerging technologies such as 5G communications, edge computing, hydrogen fuel systems, and advanced robotics will continue to expand the capabilities of unmanned aerial systems. The next decade will witness remarkable achievements in this field. So these are the final key takeaways of today's program. So today we explore the solid foundations of drone technology, flight control systems, autonomous navigation, programming methodologies, and AI integration. We learned that drones represent a convergence of mechanical engineering, electronics engineering, software engineering, and artificial intelligence. Most important thing, we recognize that innovation must always be accompanied by safety and regulatory compliance. The skills you acquire in drone technology today will create opportunities in many rapidly growing industries tomorrow. So, with this few message, once again, I thank all the members for your active participation throughout this workshop. I hope this session has expanded your understanding of autonomous drone systems with a simulation exercise and that inspired you to explore this exciting technological domain further in future. Let us continue learning, experimenting, and developing innovative solutions using drone technology. I wish you a great success in your future projects and professional endeavor. Thank you all once again. Tomorrow we will meet in the next subsequent session, drone mapping and GIS applications. Thank you all.